All right, just similar to an alkane or cycloalkane, you still remember that determine the stability, and cyclopropane ring is the least, the most unstable. All right, same thing. We do reaction on it, same concept there, and we measure the heat that it produces. All right. So in an alkane, if we do reaction, I'll take a look at this reaction real quick. You will learn this in the next chapter, chapter 8. We add two hydrogens onto alkene, make it an alkane. All right. We call this reaction hydrogenation. Right. It's hydrogenation means adding. So add hydrogen onto an alkene. All right. So when we measure the heat that's coming out that is released by this reaction, and let's determine the stability of an alkene. All right. So because it's produced right there. How does it produce? Well, because of the product is more stable than the reactant. Why it's more stable? I'll take a look. So from the reactant side, we got one pi bond, one sigma bond. All right. On the right side, it's all sigma becoming two sigma bonds, so which is more stable than a pi bond. Pi bond is more reactive. You probably have seen pi bond do reaction, but you never seen a sigma bond do reaction. It's really stable. All right. So that's the reason why this process, this reaction is exothermic, and we can measure the heat of the reaction from here. All right. All right. So it produces heat. All right. So let's say we have these three type of alkene. All right. So we have monosub, we have disub, and we have trisub alkene. All right. So they're starting with a different energy level, but after hydrogenation, make it alkene back to alkane, alkene to alkane, alkene to alkane. They all look the same. Did I? We intentionally pick these three because they have the same, the product have the same energy level, so we can compare, right? Let's take a look. They all start at the different energy level, but they all come down at the same energy level when they become the product, right? And the energy release, that tells you the stability. The more energy release, the least stable they are. The smaller energy it releases, the stable it is. Okay. All right. So look right here. So you can see that trisub alkene are the most stable, release the least amount of energy, right? Monosub is the most unstable or the least stable, release the most amount of energy. Okay. So more substitute alkene, the more stable alkene. Basically, that's what I want to say. All right. And that's the reason why. All right, relative stability of an alkene one more time. So monosub, disub, trisub, tetrasub. Tetrasub is the most stable one. All right. And if you see if they are the same amount of substituent, for example, disub here, we have trans, we have cis, we have geminal on the same carbon. All right. Trans is more stable than cis because it got steric hindrance right there. Right, and the same thing with geminal, but it has a steric hindrance right there. Geminal come from Gemini, which mean twins, right? It look like twins, but they call it geminal position right there. Geminal substituent. Anyway, so trans, cis, and geminal. All right, and we got here in this in the cyclic system, endocyclic alkene, which means alkene inside the ring is more stable than an alkene outside the ring. Okay, this from the experiment. They do the reaction, measure the heat of the reaction, and they found that the endo double bond is more stable than the exo double bond. Okay, all right. Keep this in mind. We're gonna come back and use this later when we talk about the when you produce a bunch of alkene, you have to compare stability. Okay. All right, let's try this with me. Now I still rank the stability from the most stable to the least stable. Who's the most stable right here? Any tetrasub here? A, tetrasub for sure. That's A gonna be the most stable. B, probably the least one. We have trisub, disub. Oh no, this is trisub, 1, 2, and 3. So A and E, all right. B is di, C is di as well. D also disub. Now E is tri. All right, so we're gonna go A and E. Okay, for sure. All right, we have endo. Right, so double bond inside the ring. We go endo right. This more stable right here than exo. All right, so C is next. B and D. Oh, B and D actually identical. Same compound. B and D. Yeah. Didn't say that. Cool. Good job, guys. All right, let's keep going next. We got a class activity number 1, question 1, question 2. We got the keys right here. All right, you know what to do. You know the drill. Go to the next video.